Hi, my name is John Krockmalny, and I've developed these visual tutorials to accompany any technical training format that might be delivered. In this presentation, we'll be investigating electrical current, also called amperage. There are three learning outcomes associated with this presentation. Number one, describe electrical current. Number two, identify two values making up amperage. Number three, describe how amperage is measured. When we think of flow, we may understand that flow is a movement of a mass associated with it. In this presentation, it's going to be a fluid. Air and water are examples of fluid mass that moves or flows from one point to another. Flow rates are one value representing two conditions of measurement: quantity and the timing over which that quantity is delivered. It may be important to understand that fluid flow rates happening within a medium, such as a pipe, are constant in and throughout the medium of that pipe. In terms of the flow rate of water, we may understand the term used, gallons per minute. Again, notice gallons, the quantity, and per minute, that unit of time. A review is necessary to understand flow rates. Notice that in this graphic, there is no difference in the applied pressure to initiate a flow of water. A pressure difference is required to initiate a flow of fluids. On this graphic, we have a greater pressure existing on the left side than on the right. This pressure difference initiates a flow. The flow will always travel from the point of greatest pressure to a point of lowest. We may also understand the relationship between pressure difference and flow rate. The higher the pressure difference, the greater the flow rate. The smaller the pressure difference, the smaller the flow rate. If there's going to be no pressure difference, there will be no flow. Since one energy source can be converted into another, we can set up our understanding of electrical energy utilizing another analogy involving other energy resources. Typical water circuits may be an adequate example. Substitute pressure for volts and GPM to amperage, and we can understand the same principles of electrical voltage pressure differences initiating an amperage flow. When there's a flow of electrical energy, it involves the same principles and concepts as any other flow of mass: the quantity of the mass flowing and the flow rate or unit of time. GPM, or gallons per minute, is the measuring term for fluid flow. Amperage is the electrical term involving a flow of electrical energy. Like water circuits, amperage electrical flow is constant within the conductor it is moving in. It does not speed up nor slow down in that conductor. Amperage represents a measured value involving a quantity, and that quantity delivered per unit of time. In amperage, the quantity is called a coulomb, and the delivery rate is 1 second. To understand amperage, we have to go back to the structure of the atom. We may remember that the atom has three particles: proton, neutron, and electron. The proton is positive in electrical charge and exists in the center or nucleus of the atom. The neutron is neither positive nor negative in electrical charge. It does not have an electrical charge and is positioned next to the proton and in the center nucleus of the atom. The electron is negative in electrical charge and orbits the proton and the neutron. Energy cannot be created nor destroyed, but it can be converted from one form of energy to another. The proton and neutron exist in the center and have relatively little energy. There is no great movement among these two particles. The electron, however, is constantly moving, proving it has energy. In electricity, the energy of the electron is converted into electrical energy. In this graphic, we see an electron located on the left and three atoms located to its right. When voltage pressure is applied to that extra left electron, it causes that electron to move. The force produced by the electrical voltage pressure causes this electron to collide with another. A transfer of energy happens between the electrons, like billiard balls hitting each other. The first electron collides with the second electron, transferring its energy to the second electron. The second electron now has the energy of movement that the first electron had, resulting in the movement of that second electron. The second electron now collides with the third electron. Energy is then transferred from the second electron to the third electron, resulting in the movement of the third electron. The force of collision between this third electron and the fourth results in the transfer of energy and the movement of the fourth electron. With the energy of the third electron transferred to it, the fourth electron then moves. The movement of electrons results in electrical power. Amperage results when there's an electrical voltage pressure difference between 2 points, resulting in electron flow. In a water circuit, fluid power is converted into rotational mechanical torque of the paddle wheel, also considered to be the circuit's load. In the electrical circuit, the electrical energy is converted into heat and light of a light bulb. The electrical energy could also be converted into the rotational mechanical torque of a motor, or the radiant heat of a toaster's heating element. Remember, amperage values represent two conditions, quantity and unit of time. This is how we measure flow rates. The quantity of electricity is referred to as a coulomb. Think of the coulomb as being nothing more than a container for electrons. Remember, electrons provide the energy to convert into electrical energy. This container or basket for electrons holds 6.2415 10 to the power of 18 electrons. Because of the large number, scientific notation is used to express this value. At the bottom of this graphic, we can see the actual number of electrons in one coulomb. 1 amp is the value of 1 coulomb of electrons flowing past 1 point every second unit of time. 2 amps is the value of 2 coulombs of electrons flowing past 1 point every second. Do not touch exposed live electrical circuits and related components. When utilizing electrical multimeters and other electrical test instruments, always handle the multimeter and related leads by their plastic non-conductive frames and not by the metallic portions. Utilizing multimeters and other electrical test instruments, they need to be performed while wearing the correct personal protection equipment and observing the safe protocols as referenced in the National Fire Protection Association NFPA 70E standard for electrical safety in the workplace. Depending on schematic drawing utilization, amperage could be abbreviated with an I for initiated movement of electrons or A for amps. Multimeters, configured to measure amperage, are placed in series between the source of the power and the load being measured. It is important to understand that amperage configured meters do not offer any resistance in the electrical circuit. If the meter leads are not correctly placed or the meter is not configured properly, meter damage and/or personal injury could result. The multimeter is used for low amperage measurements. Amperages of values in milliamps will typically be used. For higher amperage applications, such as measuring electrical motor amperages, it would be dangerous to break into the live and exposed electrical circuit. For this reason, clamp-on amp meters are used. Multimeters are the workhorse of the electrical trades. Multimeters can be configured for voltage, resistance, amperage, and continuity measurements. In this presentation, we'll focus on measuring for amperage. It is critically important to follow these instructions before amperage measurements are taken. If not followed, meter damage and/or personal injury could result. Using multimeters to measure amperage, we follow a process of considering what it is being measured, setting the leads, setting the selector switch, and setting the expected range. Before we take the measurement, we have to observe the circuit polarity and connect the meter to the circuit accordingly. The leads for an amperage measurement are connected to the meter as shown. The black lead is placed into the COM or common jack. The red lead is placed into the milliamp jack with the capital letter A. A stands for amperage. In this setting, you're preparing the meter to measure milliamps of current. Do not measure higher than 400 milliamps with this meter, as a risk of personal injury could result. Setting the selector switch involves rotating the indicator to read milliamps. Notice that this setting will accept amperages of both AC, shown by the sine wave, and DC, shown by the solid and dashed lines above the milliamp reading. Setting the range involves pressing the range button on the meter. Each time the range button is pushed, the displayed decimal advances one position to the right. When measuring electronic circuits that are powered with direct current voltage, polarity must be observed. When properly configured for amperage, observe polarity and take the actual measurement. Multimeter measurements for amperage must consist of these steps in order to get the proper measurement. Also understand that to measure electrical amperage current, meters are placed within or in series in the circuit, whereby all of the amperage flows through the meter. Notice on this circuit there's a break between terminal blocks 1 and 3. The amperage configured multimeter is placed into the circuit to be measured in a position where all of the amperage then flows through the meter for measurement. In this video, we see that there's a break in the conductors between terminals 1 and 3. Applying the ammeter configured multimeter leads between terminals 1 and 3, all of the amperage then flows through the meter for measurement. On high amperage circuits, such as those involving electrical motors, clamp-on ammeters are used for this measurement. Using these instruments does not expose live electrical conductors to personnel. When amperage flows in the circuit, these meters sample the flux line energy that surrounds the conductor and then provides the amperage value.